Hello, we're looking at number 1 in the study guide for the Common End of Course exam. Number 1 reads, what is the approximate length of ST with endpoints 5, 8, and 7, 15? We're looking for length, okay? So that means what we need to do is we need to find the distance between the point 5, 8, and 7, 15 on a coordinate plane. So we're going to use our distance formula. So that's just a matter of plugging in our x and our y values into our formula. Whoops. So we've got d is equal to the square root of the difference in the x coordinates, and I'm going to do 7 minus 5, and that's the difference squared, plus the difference in the y coordinates. I'm going to subtract in the same order. Okay, remember that's what our subscripts are for, to help us subtract in the same order. So I'm going to do 15 minus 8 and square that. So 7 minus 5 is 2, and 2 squared is 4. 15 minus 8 is 7, and 7 squared is 49. So the distance from the 2 points, from point S and T, is the square root of 53, which is approximately 7, if you round to the nearest hundred or nearest tenth, 7.3. So we see A is the correct answer choice. All right, let's look at number 2. Number 2 reads, the circle below is centered at the origin and contains the point -4, 2. What is the length of the diameter of the circle rounded to the nearest hundredth? So again, we need to understand that length is measured by the distance between the 2 points, and we need to understand what diameter is. Diameter goes from one point in the circle through the center to another point on the circle. And we're rounding our answer to the nearest hundredth. Okay? So if I were to draw a segment from point 4, -2 through the center to another point on the circle, I don't have a coordinate there. All right? So I couldn't use a distance formula in that case. But I do know that the center is at the origin. Okay, that's at 0, 0. Okay, so we do have a point here at 0, 0. So what I can do is find the distance from this point to this point, and then do what? Okay, double it, okay, because that would be the radius. I'll double it, and that will give me the length of the diameter. So again, I'm going to use my distance formula. And I've got 0 minus -4, or -4 minus 0. That's the difference in the x coordinates, and that's squared, plus the difference in the y coordinates. So I'm going to subtract in the same order, -2 minus 0, and that's squared. Okay, and then -4 minus 0 is -4. -4 squared is 16. And -2 minus 0 is -2. -2 squared is 4. So the distance from the radius is the square root of 20. Okay? And that's the distance for the radius. And so the diameter, we're going to double that. And so let's just say the diameter is going to equal 2 times the square root of 20, which is approximately, when we use our calculated estimate, is approximately 8.94. Okay, so our diameter, what is the approximate length of the diameter? 8.94 units. Let's move on to number 3. The endpoints of segment CD are 6, 1 and negative 4, negative 1. Find the midpoint of CD. So we're going to use our midpoint formula. If you go to your reference sheet, you can find what you do to find the midpoint of a segment. It's simply just add the x-coordinates of the endpoints and divide by 2. That gives you the x-coordinate of the midpoint. And then add the y-coordinates of the endpoints and divide by 2, and that gives you the y-coordinate of the midpoint. So we're going to add negative 4 and 6, negative 4 and 6, and divide by 2. And 1 plus negative 1, and divide by 2. So that's going to give us our x and y coordinates. Negative 4 plus 6 is 2. 2 divided by 2 is 1. And 1 plus negative 1 is 0. 0 divided by anything is 0. So our midpoint is at 1, 0. That's exactly halfway between, negative 4 to 1. Negative 4, negative 1 to 1, 0 is the same distance as 1, 0 to 6, 1. But anyways, here's our midpoint. Let's see how much time I've used up. Okay, so I'm going to stop here for this one.